Hey everyone, so in this video I'm going to talk about analyzing factored polynomials, and specifically I'm going to talk about how to analyze the degree of that polynomial, its symmetry, its end behavior, its zeros, and all those important things of polynomials. But the first thing I want to talk about is two basic functions. The first function being y equals x squared, and the second function being y equals x cubed. The reason why I picked these two is because they are the most basic parent functions, with one having an even degree, which would be y equals x squared, and one having an odd degree, which would be y equals x cubed. Y equals x squared looks like a parabola. At the origin, it's a U shape. And then y equals x cubed, you should know by now, it's like this squiggle that's directly over the origin. Okay, so the first thing I want to talk about with these two things is, first off, this has an even degree. And it is also considered an even function. And the reason why it is called an even function with an even degree is because it has symmetry over the y-axis. What you need to understand is that an even function has symmetry over the y-axis. Now, that being said, the other polynomial on the right has an odd degree. And this one is considered an odd function because it has symmetry over the origin. Now, there are several ways to figure out symmetry over the origin. First off, this point here is 1, 1, and this point here is negative 1, negative 1. If you notice, the x and y values are totally inverted, meaning they have different signs. That's one way to understand if it's symmetry over the origin. Also, some people like to draw a half circle. If it makes a full semicircle 180-degree rotation, it is an odd function. Okay, so even degree, odd degree, even function, odd function. To be an even function, odd function, you need to look for the symmetry. To be an even degree or an odd degree, you look for the degree of the polynomial. Now, the next thing I want to talk about is what the degree does to the end behavior. The end behavior for an even degree is always the same, meaning that it will always go in the same direction, so either both up or both down. But with an odd degree polynomial, the end behavior will always be different, so either one going down and one going up, or the other way around, where one will go up and one will go down. Okay, now I do want to talk about one thing. What if I changed these polynomials? What if I made it y equals x minus 2 squared? What that will do to x squared is it will move x squared to the right 2 units because it's negative on the inside. Now, even though the degree is even, it is not an even function because there is no symmetry over the y-axis, meaning I can't fold it over like a book. And same thing goes with the odd functions. If I change y equals x cubed to y equals x plus 2 cubed, this means I would move over the cubic function to the left 2, and it'll look like this. Even though it has an odd degree of 3 up there, it is still not an odd function. The reason why is because if you look at the symmetry, it is not directly over the origin. That point would have to be on the other side of the origin, and that is not the case. So even though this is an odd degree, it is not considered an odd function because it lacks symmetry. Now I'm going to analyze a few functions here for the rest of the video. The first one I want to talk about is its zeros. To solve for the zeros, you set it equal to 0, and you set each piece equal to 0. And this will help us solve for our zeros. To get your zeros, you would add 4. So one of my zeros is x equals 4. I would add 1. 1 would be another 1. Subtract 3. And I would get negative 3. So my zeros are negative 3, 1, and 4, and you can see those on the graph. They also happen to be the solutions and the x-intercepts because they satisfy where it crosses the x-axis, and if you plug these in, it'll make the equation equal to 0. The degree of this polynomial is 3, and the reason why is because each of these have a power of 1. 1, 1, and 1. Power of 3 together. So that's your degree. Also, if you notice, each value happens once. And if you remember from our discussion a few lessons ago, each of these happen once, so the multiplicities are 1. So if you add the multiplicities up, you also get the degree. The end behavior is different because one goes to positive infinity and the other one goes to negative infinity. Now, is this an even function, an odd function, or a neither function? This function is neither even or odd, because although it does look like odd, it does not directly cross over the origin, and this point is not a direct 180 rotation here, and also they're not exactly the point directly over the origin, so it's neither because it lacks symmetry. Next question, the zeros, same idea, set it equal to 0. This would be x equals 0 for the first piece, x equals -4 for this one, x equals 2, and x equals 5. Those are my zeros. They are also my solutions, and they are also my x-intercepts. The degree of this one is 1, 2, 3, 4, being an even degree. That being said, because it's an even degree, the end behaviors are the same. They both go up to positive infinity. Now for this one, is this function even, odd, or neither? Now because it has an even degree, the only one that really could be is even. And like I said, could. If you look at the graph, it does not have symmetry over the y because this point would have to be right there. So it's still considered neither because it lacks symmetry. Alright, so with the next one I'm going to do the same thing. To find my zeros, I will set it equal to 0. Each piece will get set equal to 0 to make a 0 of x equals 2, x equals -2. And what I want to talk about is this piece right here. If I set that equal to 0 and solve for x, I get x squared equals -1. Now this one is very special because when you take the square root of -1, you end up getting I, and not just I, plus or minus I, because there are two outcomes when you take a square root. So my zeros are -2, 2, and plus or minus I. So my zeros include complex zeros. This is my complex zero. They are still considered solutions, but I only have two x-intercepts now because my complex or imaginary, whatever you want to call I, they do not occur on the x-intercept. The only ones we will see is 2 and -2. The degree of this one is also 4, like the last problem, and the reason why is because this has two answers that come out of it. Also, the degree is 2 inside of that piece. There is one answer out of here and one answer out of here. Also, the degree is 1 and 1 here. If you add these up, you get 4. Now, because the degree is even, the end behavior is the same, and in this case, they both go to positive infinity, up and up. Now, is an even function an odd function, or neither even or odd? Well, let's look at the symmetry. The degree is 4, so that's even, so it's probably an even function, but we're going to check with the symmetry. If it's an even function, it has symmetry over the y, and this one does have symmetry over the y. When you look at this, if you were to fold this in half over the y-axis, you would have the exact same image on the other side, like a mirror. So I would say this is even because there is symmetry over the y-axis.